Last page of the practice assessment, more math and analysis to do. This time dealing with significant figures on a lot of this stuff. First thing we need to do is calculate the volume of the block of wood in cubic centimeters using significant figures. Volume is length times width times height. So 6.50 times 2.25 times 1.55. Calculator says 22.66875. We need to round for significant figures. We have 3 significant figures in our first measurement. That 0 counts because it's trailing with a decimal point. 3 significant figures in our second measurement. 3 significant figures in our third one, which means our final answer needs to have 3 significant figures. Start at the left, work your way right. That's 1 significant figure, 2 significant figures, 3 significant figures. The cutoff is there. The 6 is followed by a 6, so we'll round it up. All the extra stuff after the decimal point gets dropped. 22.7. And I already put the unit there, so there's really no reason to write it down again. Next thing we have to do is we have to go into the density calculation. And again, this is exactly like we did in our lab. You calculated volumes of wooden blocks, you calculated their densities. This is all exactly the same as that. Density is the mass divided by the volume. We've got the mass here, 9.0 grams. The volume we just calculated, 22.7 centimeters cubed. So 9 divided by 22.7, calculator says 0.39647577709. And again, we got to round for significant figures. The mass had 2, trailing 0 with a decimal point, so it counts. The volume has 3. We have to go with the smaller number. We don't count the 0 as a significant figure. It's a leading 0, they never count. So our first significant figure is the 3. Second significant figure is going to be the 9. We're rounding it off at the 9. Followed by a 6, so this rounds up to 10. The 9 changes to a 0. The 3 changes to a 4. So the number we're going to record is 40. Already got the units there. It's grams over centimeters cubed. 0.40, not 40. 0.40. And that is our answer. Next thing we got to do is some metric conversion. We have to convert from centimeters to millimeters. King Henry died by drinking chocolate milk. From centi to milli. From here to there. We are going one place to the right. So we're going to take our decimal points and move them one place to the right. Preserving significant figures. That 0 has to stay because it's a significant figure. We have 3 there, we need 3 there. This ends up being 22.5. And this ends up being 15.5. Down here we're going from gram to milli. Gram is a base unit. So we're starting here this time. Still going to milli. 1, 2, 3 places this time to the right. We don't count where we start, so kind of ignore that. 1, 2, 3 places to the right. 1, 2, 3 places to the right. We got to fill the empty place values in with zeros. It would be 9,000. Put a bar over that 0 so we know it's a significant figure, that it counts. Those are the metric conversions. Last column then is the English metric conversions, the ones that involve the factor label method. I've given you the equivalences to use. For the inch centimeter ones, it'll be 1 inch equals 2.54 centimeters. So we start with the centimeter measurement, 6.50 centimeters over 1. Set this equivalence up so the centimeters cancel. So 1 inch on top, 2.54 centimeters on the bottom. Whenever the 1's on top, you divide by the number on the bottom. So 6.5 divided by 2.54. We get 2.55905518. Again, we're going to use significant figures. It's all based on what you started with. Because we started with 3 significant figures in our original measurement, we're going to round our answer to 3 significant figures, 2.56 inches. Now, once we figured out 1, all the rest are going to be the same. This is just going to be 2.25 here this time. It's still centimeters, so we still have to put centimeters on the bottom. So we're going to take 2.25 divided by 2.54. Again, we get this really long number. It's 0.8858267717, and a real long number. We're looking at our original value. It had 3 significant figures, so we're going to round this to 3 significant figures as well. And when you do that, you get 0.886. And then finally, the 1.55. Again, everything about the setup is going to be the same. We're still converting from centimeters to inches. So it's still centimeters here. It's still centimeters down here to cancel. 1.55 divided by 2.54. Again, we have to round for significant figures. Again, we started with 3. So this would be 0.610. The 0 has to be on the end to give it the 3 significant figures that it needs. Finally, the milligram to ounce. That's where the second equivalence comes in. Again, start with our gram measurement, which was 9.0. It's over 1. Set this up so grams cancel. So we have it in the numerator here. We'll meet it in the denominator over here. The 28.3 goes on the bottom. The 1 ounce goes on top. Those grams will cancel. Again, when the 1's on top, divide by the number on the bottom. That's what we get. We're limited by significant figures. We have 2 in our original measurement. We're going to round this to 2. 0 doesn't count because it's leading. So that'll be the first one. That'll be the second one. 8 rounds this up to a 2. Everything else gets dropped because it's after the decimal point. 0.32 is that answer. So this is the table that involves, I think, the most work. Getting your metric conversions done right, getting your English to metric conversions done right. Good news is once you start with these ones over here, the others just kind of follow. So you really only have to set the first one up and then you know what to do from that point on. Bottom table, much smaller, less to do. We have to convert the meters to millimeters. King Henry died by drinking chocolate milk. This is a base unit. Single letter is always a base, so you're starting there. And we're going over to milli. That's 3 places. And again, cover up where you start. We're going 3 places. We're going over to the right. 1, 2, 3. Fill the empty place values with zeros. 1, 2, 3. Fill the empty place values with zeros. 1, 2, 3. Fill the empty place values with zeros. Doesn't say anything on this section about significant figures, but they do just take care of themselves. There was 1 in the beginning number, there's still 1 in the end. 3 in the beginning numbers, 3, 1 here, 1 here, 1 here, 1 here, it's all good. Now we have to calculate the volume in millimeters cubed. Again, length times width times height. So it's 500 times 300 times 200. And that gives us a big number. The 3 with 7 zeros. And it asks for the answer in scientific notation. So what we're going to have to do is take the decimal point and move it so that there's 1 non-zero number in front of it. If there's no decimal point in your number, you always assume it's at the end. So it's coming from here to there. So we get 3 times 10 to some number. The exponent is how many places we move the decimal point. We move it 1, 2, 3, 4, 5, 6, 7 places. It's positive if we move it to the left. It's negative if we move it to the right. Because we move to the left, it's going to stay positive. 3 times 10 to the 7th. And the unit's already there. Millimeters cubed.